Good morning. Welcome to Mission Control Houston. You're looking at a live view in the International Space Station Flight Control Room. This is the spot where there's always a team on duty, keeping an eye on operation of the space station systems and coordinating the work of control centers around the world as the Expedition 55 crew members press on with their mission of discovery. Scientific research has been a focus of the onboard activity this week. That includes some groundbreaking genetic research being done inside the station's laboratory, as well as materials research going on the outside of the vehicle.
Station on Space to Ground.
Welcome to Space to Ground. I'm Isidro Reyna. This week, the science continued on the International Space Station. The crew worked on the Genes in Space investigation, a student-designed experiment that tests whether the polymerase chain reaction can be used to study DNA alterations on board the station. Spaceflight causes many changes to the human body, including alterations in DNA and a weakened immune system. Understanding whether these two processes are linked is important for safeguarding crew health. For the experiment, the crew processed samples in the miniature polymerase chain reaction. Data gathered may be valuable in the development of procedures to maintain astronaut health and prevent an increased risk of cancer on deep space missions. Almost every product we use has a shelf life. From milk and meat to laundry detergent and batteries, it's important to know when it's safe to use a product and when it's time to replace it. But what about materials used for spacecraft? The New Materials International Space Station Experiment Flight Facility, or MISSI-FF, was removed from Dragon's trunk and installed on the station this week as the newest addition to the National Lab. Developed by Alpha Space, the platform will host government and commercial payloads that want to expose different materials to the harsh environment of space. Just about anything that makes up a spacecraft, from metals to circuitry, cameras and computer boards can be installed to see how they stand up to the extreme thermal and vacuum environment. The first batch of materials on board will remain outside the station for 1 year, testing polymers that could shield missions from radiation, studying how to withstand atomic oxygen in space, and evaluating 3D printed samples. This week's question comes from Leonard. He wants to know how astronauts shower or bathe on the space station. Well, Leonard, astronauts have been living for more than a decade aboard the space station and have developed a few tricks that make these everyday tasks easier. Astronauts use special kinds of soap and shampoo. These soaps do not need water to rinse. And astronauts must use them carefully since they don't want soap bubbles to go all over the place. After washing, they use a towel to dry off, but they do not rinse. These special soaps and shampoos were made for hospitals for patients who cannot get into the water. Keep sending in your questions using the hashtag #SpaceToGround. We'll see you next week.
In learning more about such seemingly simple things as bathing, the International Space Station is helping us humans know what it'll take to make successful journeys out into the solar system someday, to Mars and other destinations. Here are a few more examples of how the station is building the missions of the future.
So you want to go to Mars. How does NASA's International Space Station help us extend human presence into deep space? In the future, when astronauts land on Mars, it will be thanks to some important lessons that we learned on the International Space Station. Rewind. 240 miles above the Earth, the International Space Station is where we currently live and work in space. Here's what we've learned so far. First, there's taking care of our astronauts. Prolonged weightlessness can lead to muscle and bone loss, vision changes, balance, and coordination loss. Thanks to the space station, countermeasures are being developed to keep astronauts healthy for long-duration missions. Then there's the equipment. Spacecraft communication, water recycling, air, and power production are all being test-driven on the International Space Station. What we learn about operating and maintaining our gear in the harshness of space will pave the way for future missions into our solar system. And that's how the space station is helping us extend human presence into deep space. For more information, visit this NASA website.
NASA's effort to prepare for future exploration includes the development of the spaceship that will carry astronauts beyond low Earth orbit one day. NASA is aiming to complete manufacturing of the major hardware by the end of this year to support Exploration Mission 1. That'll be the first launch of the Orion spacecraft using the new Space Launch System rocket and the attendant ground systems. This flight will not have humans on board, but it will pave the way for the missions that will. Exploration Mission 1 will not carry humans on board. The first flight test of Orion and the Space Launch System that will have people on board is targeted for the early 2020s. Now, Orion is being designed to protect the human crew members from the harsh environment of space, and that includes the radiation that these men and women will encounter along the trip. NASA's Human Research Program has been looking into several ways to try to shield astronauts from galactic cosmic radiation.
Just as early explorers had to endure weather as they traveled to new lands and explored new areas, astronauts, when they go on space travel outside the Earth's magnetic field, will have to endure space weather. This space weather would include things like galactic cosmic rays, which are remnants from supernova, and also solar storms, which include things like solar particle events and coronal mass ejections. So as astronauts are traveling to Mars, they're going to be enduring the space weather, and it's harmful to the body in a couple different ways. There's an in-flight risk from things like solar storms, and those really present acute radiation sickness type issues that would have to be dealt with operationally in real time. And then there's also long-term late effects like cancer, cardiovascular disease, and possible central nervous system effects. And those are more possibly late-term effects that would come into play after the mission. So just like the early explorers, NASA's mission is to bring all of the astronauts home safely. And to do that, we're investing and looking into these shield design strategies that include ways that mitigate exposure from all forms of space weather. So we look at habitat design and overall vehicle optimization to reduce the in-flight risk from solar storms. But then we're also looking at material design and other vehicle optimization strategies to reduce the risk from long-term exposure to galactic cosmic rays.
The International Space Station's role in preparing for future exploration includes being a test bed for the technologies we'll need to make those trips. Things like the water recovery system that turns moisture from a number of sources into safe, clean drinking water. Here's how that works. the more than 17 years since there have been crews on the International Space Station, scientists from more than 100 countries have been able to take advantage of space shuttles and Soyuzes, Russian, Japanese, and European resupply vehicles, and commercial cargo ships to get their experiments to space. And the station has been hosting science for long enough now that some research results have become new products, which are in turn helping people in their daily lives on Earth.
It is getting easier and easier to get research to space. For example, there's a drug called Prolia that has came to market in about 2011. And that drug, the mechanism of function of that drug was tested during space station assembly. Well, now if I'm talking to a group of women about osteoporosis, I can talk about how space flight, is linked to osteoporosis, and this drug is out there. And there are women who will say, hey, I'm taking that medication. So it's just much easier now to relate because we've had enough time to have those results come out and really start affecting people's lives. Everything's different today because you're really able to use the space station as a real laboratory. Now that we're doing 350 experiments at a time, we are looking 3 years from now at this huge bow wave of research that results that will be coming out, and that research is really going to be having an impact in our country. One of the things that's really exciting to me right now is the number of new researchers that we're talking to. But now with the access opened up, and with the funding sources opened up, so it doesn't just have to be NASA, it can be the private sector, it can be other government agencies, then the best ideas all have a way to get to space. Over 96 nations in the world have done some aspect of either education or research on the space station so far today. And that access is broader and broader as we have users coming in from countries all around the world, people trying experiments, and of course science is international. So what it means is through the network of international scientific collaboration, almost any scientist in the world who can find funding for their research is going to be able to find a way to access the laboratory.
Along with the research that's being done inside the space station's laboratory modules, the station serves as a platform for science that is targeting the Earth. Researchers who are interested in learning more about lightning and thunderstorms are using the station to study transient luminous events. Those are storm-related phenomena that we can't see from down here on Earth.
A display of lights above the storm. Presented by Science at NASA. In 2015, European Space Agency, or ESA, astronaut Andreas Mogensen was on board the International Space Station, or ISS, photographing the tops of thunderstorms from Earth orbit. And he saw something very interesting indeed: blue jets. Blue jets are a type of transient luminous event, or TLE, flashes and glows that appear above storms that are results of activity occurring in and below those storms. Blue jets pulse from the tops of intense thunderstorms and reach up toward the edge of space. In January 2017, researchers at Denmark's National Space Institute published their analysis of his observations in Geophysical Research Letters. Mogensen was able to capture clear video as the station flew over the Bay of Bengal, and they were amazed by what that video showed. Olivier Chanrion, lead author of the publication, reported that during 160 seconds of video footage, 245 pulsating blue discharges were observed, corresponding to a rate of about 90 per minute. One of the blue jets observed reached 25 miles or 40 kilometers above sea level. Visual evidence of TLEs wasn't available until 1989. Early evidence included red sprites photographed by cameras on board the space shuttle and photographs taken during a NASA and University of Alaska airborne campaign. Red sprites are glows in the upper atmosphere tied to the presence of large lightning flashes, but not attached to the clouds themselves. In recent years, the ISS has afforded astronauts the opportunity to photograph a number of natural light shows produced at the tops of thunderstorms. A 2013 study by researchers from the French Alternative Energies and Atomic Energy Commission analyzed pictures from the NASA Crew Earth Observations Facility aboard the station. The pictures revealed 15 sprites and their apparent lightning flashes. In August 2015, the Expedition 44 crew on board the station photographed red sprites over 2 different storms within 3 minutes of one another. First over the American Midwest, and then near the coast of El Salvador. These sprites reached as high as 62 miles or 100 kilometers above the surface of the Earth. All of these studies are contributing to researchers' understanding of lightning and thunderstorms, how they form and develop over time, and why storms produce different TLEs in different circumstances. However, according to Tim Lang, atmospheric scientist at NASA's Marshall Space Flight Center, TLE studies have been, to an extent, fortunate observation. We've gotten better at finding them, but it's mostly case-based analysis. NASA and partner agencies are advancing in their efforts to make continuous storm observations. NASA's Lightning Imaging Sensor, or LISS, was installed on the International Space Station in February 2017 as part of the DoD Space Test Program. LISS on the station is the latest in a line of instruments used to locate and detect lightning over a large region of the Earth's surface. The Atmosphere-Space Interactions Monitor, or ASIM, will be installed outside Europe's Columbus Laboratory on the ISS later this year. Torsten Neubert, ASIM principal investigator, says, the instruments will monitor thunderstorms and their effects on Earth's atmosphere, gathering information about blue jets and other TLEs, as well as flashes of X and gamma rays. LISS and ASIM will be providing data that gives researchers the opportunity to analyze storms from both below and above. All of these studies are adding to our knowledge of how storms evolve and change, helping improve storm models that could lead to better predictions and forecasts. For more science from above the clouds, visit www.nasa.gov/station. For electrifying updates, stay tuned to science.nasa.gov.
Even though the International Space Station is zooming along at 5 miles a second, it provides a great vantage point for pleasure photography of the Earth from 250 miles overhead. In this Speedy Time segment, recorded just before his return to Earth last year, astronaut Jack Fisher showed off some of the station's picture windows and introduced crewmates who talked about their reasons for spending time with their cameras pointed toward home.
Hi everybody, and welcome to another episode of Speedy Time. Since Peggy, me, and Fyodor are going to be leaving soon, we wanted to introduce you to the new crew and also tell you about one of the coolest things that we do on the space station, photography. All of these guys are experienced. They've all flown before, and they're all big photographers. So I wanted to introduce you, and then they can tell you about some of the reasons why we take pictures on the space station. First off, we have Sergey ISS, we have Astro Comrade, Astro Paulo, and my commander, Fyodor Yurchikin, who is kind of like the Jedi Yoda master of onboard photography. He's been helping me a lot. So let's go through some of the reasons why we take pictures.
First of all, it's just amazing. We want to share this beauty of our planet with all of you.
We also do real-time monitoring of extreme weather events, like the floods in Venezuela we just photographed.
And we like to document the changes that are taking place on Earth. We can see rivers, we can see glaciers, we can see a lot of things, and we document those.
The Earth is our home. For what reason I take these pictures? And we should save this planet, this amazing, beautiful, brilliant planet for our child. Not for yours, not for mine, for our child. Thanks.
All right. I told you he was the Jedi Yoda master of onboard photography. Now let's check out one other set of windows that we have in the cupola. Come on. Thanks, guys. We're almost there. If I haven't shown you before, this amazing place is the cupola, the center of onboard photography nirvana. 7 windows of extreme viewing pleasure. They can look at the Earth, the station, or even around to the stars. It's no wonder why we spend so much time with big old cameras in our hands. And that is how we're trying to share this experience with you and help monitor the Earth for our future. And that's it for this episode of Speedy Time. See you next time.
Most of the International Space Station crew members spend a good bit of their time on orbit looking down at the Earth. On his most recent mission, astronaut Jeff Williams spent time pointing an ultra-high-definition video camera down at the planet. Here he shares some of those images and talks about the beauty of the planet, the variety of things to see, and the value of sharing that perspective with everyone who can't go to orbit in person.
I don't remember exactly where we were the first time I viewed the Earth, but I remember getting out of the spacesuits in the middeck of the space shuttle and then floating back up and then having a chance to actually get my full view out the window, to get close to the window in the view of the Earth. And what struck me was just the overall beauty of the planet, and specifically with the blues of the oceans and the whites of the cloud formation. I put a high priority on photography and video out the window of the Earth. You see things at a different scale, and I think you can grow in your appreciation for what the Earth has to offer to support our livelihood, to support civilizations. And now we can see it in a global scale and maybe grow in our appreciation of those things that are unique to Earth. To view the Earth from space, of course, especially from a photographer's point of view, it's a target-rich environment. The ocean currents and the vastness of the oceans, and in particular in sun glint, the cloud formations and other weather patterns are a never-ending varieties. The different landforms that you have show themselves in different ways. Forested areas are much different than plains. Agriculture stands out. You can see elements of the culture and the history of the area just through the patterns of agriculture. Sand dunes became one of my favorite things to take pictures of. You also have the evidence of civilization and habitation on the Earth. Every sunset, every sunrise is unique, especially in its patterns of cloud formations that the sun sets or rises from behind. when you finish and you're back on the Earth, the memories diminish quickly. So to capture the memories, to be able to bring back the experience to others, and viewing this planet, now we can see it in a global scale and maybe grow in our appreciation of those things that are unique to Earth.
If you'd like to get another look at any of the stories we featured today, check us out on YouTube and Facebook, and there are the addresses right there in the handy blue box. You'll get a look at these and a lot of other great things that we've posted there about NASA and America's human spaceflight program. And in the case of that last piece, which we call Jeff's Earth, there are even links to the ultra-high definition version of that, as well as links to the ultra-high definition source material. You can download that and look at it at home yourself. If you're interested in good conversation about space exploration, check out Houston, We Have a Podcast. It features folks here at NASA talking about their work, their personal experiences on the job. We post new episodes on Fridays. Today, April 13th, with NASA still taking applications for new flight directors, my colleague Gary Jordan talks with T.J. Creamer, one-time Space Station Expedition crew member who's now a flight director. They discuss his journey to that role and the role of the flight director in human spaceflight. Go to www.nasa.gov/Johnson/HWHAP, as in, altogether, Houston, We Have a Podcast. You'll find all the episodes there. You can also listen to them on SoundCloud and on iTunes. This is Mission Control, Houston.